This screencast is going to discuss a little bit about pressure, the types of pressure, how to convert from one to another, how to use them in calculations, and so forth. Just be a quick overview. So the first kind of pressure we're going to talk about, let's use a big tall glass of water and talk about fluid pressure. If we put a hole in that glass, then the pressure that fluid exerts would be equal to the pressure you would have to exert on a cork to fill that hole, right? So the forces counterbalance each other. And we know that pressure is a force over an area. There's many different units, but let's go with SI. We know that we could write force in newtons, and we'll just choose meters squared. And so very typically you can see a pressure in newtons per meter squared. That's also written as a Pascal. Other units you might see atmosphere, PSI, millimeters of mercury, bar, and of course pascals. The next type I want to mention is what's considered hydrostatic pressure. And that's the idea that this fluid has a weight to it. And so we're going to take whatever the pressure at the top of that water is and the weight of the water, add those pressures together, and then that gives us our hydrostatic pressure at the bottom. Typically, if this is open atmosphere, we'll refer to this as atmospheric pressure, maybe P naught, an initial pressure, and then the weight of the fluid. And so we'll write that as the total pressure here, the hydrostatic pressure is P naught, the fluid is rho GH. And you're probably wondering, how is rho GH a pressure, or does it have the same units? Right? If we write out rho GH, we know that it's a mass over a volume, and we're multiplying that by an acceleration and a height. And so we can see that the height over the volume, we get a mass times acceleration over an area. Mass times acceleration is a force, force over area is a pressure. And so those units do work out. And so that's how we calculate the hydrostatic pressure. Another type of pressure you're going to hear about is head pressure. And what that is if we create this hypothetical column of this water, and we just refer to that column, then we could call this water having a head pressure of whatever its height is. And therefore, we're going to refer to the head pressure as the height of the fluid, and that's regardless of the diameter of that fluid. It could be very large or very small. It's whatever height that column is. And so in this case, maybe it's 2 meters. And so we're going to say that this is 2 meters of water. And it's important to designate whatever fluid that is so that we could say that we have a hypothetical column of 2 meters of water, therefore that's the head pressure of the water. And we may want to convert that head pressure to a real pressure, like atmospheres or PSI, and I don't mean real necessarily, but something that you could maybe translate and compare to other systems. That case, again, is just going to be very similar to what we saw over here. And so it's the density of the fluid times gravity times the head of that fluid. That gives us whatever the pressure of that fluid is at the bottom. Let's do an example. So here we're given a situation where you're diving underwater, and we want to know what the pressure on those eardrums of yours are, in bar specifically, that's acting there. And we're given the atmospheric pressure as 1 bar. And so all we know is that we're 15 feet underwater when our ears start hurting. And there's a couple conversion factors I've pulled out of a book for you that you could use. Let's go back to the idea of using a head pressure, simplifying this whole situation. Instead of trying to figure out the exact weight of all the fluid acting on your ears, we could say that you're at a depth of 15 feet. So the head pressure, in this case, is 15 feet of water. And we know that atmospheric pressure of 1 bar, we could convert that over to a pressure related to feet of water. And so in this case, the total pressure is going to be the initial pressure plus that head pressure. We're looking at 33.5 plus 15, and that's going to give us 48.5 feet of water acting on our ears. Now we want it in bar, we just convert it over. And so this comes out to about 1.45 bar. That we could use that head pressure, simplify this entire calculation, and then convert it over to a pressure that's acting at that point.